Hi everyone, our project is What Does Happiness Mean to You? Just some background and motivation. The World Happiness Report is a survey of the state of global happiness, which ranks 155 countries by their happiness levels. Being able to predict the features that contribute to happiness can be effective in assessing the progress of nations and allow for the use of happiness indicators to better inform policymaking decisions. So we as a group wanted to analyze the report more in depth. The reports we're dealing with are found on Kaggle with 5 reports from 2015 to 2019 with around 155 samples per set and various columns such as GDP, life expectancy, and so on. Our research problem is twofold. In part one, we want to rank the contributions features that factor into the country's happiness score, and in part two, see if the region of a sample can be predicted. Moving on to methodology, first to pre-process and combine the data, we dropped columns that are not in all reports and renamed columns for the final combined data frame with a new year column for identification. All features are pre-processed of a mean of 0 and univariance. We use standardization to account for potential scoring. In part one, in seeing if a happiness score can be predicted from the prioritization of assumed contributions, the happiness scores are our target, and we train a linear regression model to data with a k-fold cross-validation approach, and again with selected features after looking at the Pearson correlation. We use MSE for evaluation. In part two, to determine if the region of the sample can be predicted, we use the decision tree classifier where our target label is region, and region is only found in the 2015 and 2016 report. We generate separate target Y data frames for each region with information on if a sample is of or is not of that region. We created decision trees by year and for 5 of the 10 regions. Those 5 regions are those with more than 20 samples to gain information to see if different levels of contribution of features to happiness by region.
All right, so for the results, for the first half of the project, using a linear regression model, we use the whole of the pre-processed data for the training and testing sets. This table shows some of the results of the modeling. The first row here holds the values of the linear regression coefficients for each of the features. We also calculated the average MSE scores over the 4 k-folds for the training and testing sets. Over multiple runs, the MSE scores stayed relatively around 30%. And here you can see we created a correlation matrix for the features that were included after pre-processing, as well as our target value happiness score. After looking at the matrix, we concluded that the most relevant or highly correlated features were GDP per capita, healthy life expectancy, and social support, along with freedom. Each of these had correlation scores above 0.5, while perceptions of corruption and generosity fell below. Thus, we also performed linear regression on the data with a subset of those more relevant features. We got very similar MSE scores, which is desirable as we reduce the complexity of the problem and number of features in the data set.
Let's look at results for part two, the part where we're using decision trees to see how different features define a region. We have 4 trees, 2 per year, and in the 2015 train, we see that nodes are being split by features until the item gets classified to one of the regions. And the logic works the same for the other trees on the slide. We can compare the different years to see how regions may have evolved. And interestingly enough, happiness score was not a split factor for any node in the tree, perhaps indicating that regions are not well defined by happiness score. Here's another way that we're visualizing how features define regions. We have 1 tree for each of these 5 regions, and in each tree, we keep splitting by feature until we have determined whether an item belongs to a region or not. You can see just from the shape itself that regions are defined pretty differently by the feature set. And thank you.